Production and factory settings bring their own set of hurdles for wireless connections. Harsh conditions, both indoors and out, create a daunting task for engineers to work through. Now let me tell you, those engineers ain't looking to back down from a challenge like this, no sir. This here's where we gather round to tackle them hurdles, swap thoughts, and lend a hand. Welcome to the Industrial Wi-Fi Shop with your hosts, Scott and Jeremy.
Hello, everybody, and welcome to the one-year birthday episode of the Industrial Wi-Fi Shop. My name is Scott McNeil. With me, as always, my co-host, Jeremy Baker. Say hi, Jeremy.
Hello.
He's a man of so many words. Super excited this go around for our anniversary episode. We've got some great people hanging out with us today from R3 Solutions with some really interesting tech that I think is going to be a great conversation. But before we dive into that, I want to talk about a couple of things. First up, for our one-year anniversary, we have teamed up with CWIDP again. Have two copies of the CWIDP, the Certified Wireless IoT Design Professional Study Guide. And I cannot wait to give this away. When you check the show notes, there will be a link. There will be, just like last time, there will be two winners. I will be choosing a winner from IT and choosing a winner from OT. Last time my daughter did the drawing. This time my son will, and it'll be a good time. So it's our one-year anniversary giveaway. And I hope everybody from IT and OT can toss their hat in the ring and see who gets these. So welcome. A couple of other quick announcements that I wanted to go through. We have some more WICO events coming up on 5/14. There will be a WICO event in Chapel Hill, North Carolina. This will be our second one there, and I'm super excited. I'll be presenting, not unsure what yet, or if I'm going to do another lab. But when Dawn kind of lets me know what all she's got lined up, we'll make adjustments from there. And Jeremy, 5/29 in Nashville, are you still planning on presenting at that one?
Yep.
Okay, so another WICO event, 5/29. And Jeremy, you are going to be doing CURWB stuff, correct?
Yeah, I'm gonna do set up some test radios and then do some software demo for some tools that we have written.
Awesome. Looking forward to that. And last but not least, WLPC is right around the corner. And I was talking a little bit last episode that our beloved Jeremy Baker is going to be doing a 10 talk. He could have been doing a longer one, but he didn't check his email in time. So he's got a 10 talk going on. What are you going to be yakking about on your 10 talk, Jeremy?
It's going to be on how we do site surveys of machine cells or access limited spaces. So I'm probably going to talk about, well, I don't want to give away too much, but essentially like how you validate and verify signal strength and throughput in machine cells or areas with limited access to humans.
Oh, that's
so like, before you have like ridership or something like that.
Well, that's awesome. That's going to be, I'm sad I can't make it this year, so I'm going to miss that in person. So everybody, be sure you hang out for his 10 talk and give him lots of positive feedback. So today we are talking with the cast and crew of R3 Solutions, and I have got 3 of their cast members here hanging out with us today, and I'm going to let you guys go through and introduce yourselves and let us know what your role is and how long you've been with the company. So Florian, let's start off with you, buddy.
Yeah, hi guys. I'm very happy to be here and thanks for the opportunity, Scott and Jeremy. So my name is Florian Bonanati. I'm co-CEO of R3. I'm with R3 directly from the start. I'm also one of the founders, and this is now our 10th year, so quite some time. So I'm happy to do this show with you and to talk more about our ring technology, which is one thing we do at R3, and give you more updates on that.
Awesome. Looking forward to it. Curtis, we've been talking to you for a while. If you could introduce yourself.
Yeah, sure thing. My name's Curtis Combs. I'm an applications engineer with R3. I came on a little over a year or so ago, primarily in the U.S. space operations. I'll do commissioning, and customer care, customer service work.
Awesome. And we also have with us Meg, even though on my screen she's listed as Sarah because her daughter hijacked her laptop
That's right.
and has not given it back to her. Meg, tell us a little about yourself, please, ma'am.
All right. Thanks for having me. My name is Meg Locascio. I've been with R3 for a little less than, I guess, a half a year now. Joined them back in the third quarter of 2024. Got a huge background experience in wireless, so I was kind of excited to come and check out this product and introduce it into the industrial world. My role is to basically, help share the brand and let all the folks in the United States. I'm located here in Charlotte, North Carolina, so we're interested in making sure that the United States industrial industry is aware of this, what I consider a fairly fantastic wireless product here.
Well, that's awesome. Thank you guys for taking the time out to be here. I really appreciate it. We've got a lot of listeners, both from the wireless community and the specifically the OT community. And so we try to share as much information as possible and to get it out there. But, the driving point of this, and Jeremy brought you guys attention, we looked at it and saw that the root of everything was this wireless token ring architecture, and that I have never seen that in wireless before personally. I'm old enough that I remember token ring out in the field in the very beginnings of my career. It was in the process of being, phased out for Ethernet and whatnot. And so remembering how that worked hardline, I was really interested to see what that was how that was gonna translate wireless wise. And so Curtis was able to send me a couple lab radios, and it's been a lot of fun playing with those and seeing how it works. But, I'm old. I remember token ring and some of the basics and whatnot. So for those out there who are really not as familiar with token ring, what is token ring? So it was a technology developed by IBM back in the early 70s. And then later on, around 89, IEEE did standardize it as 802.5. And how it works is it takes a token and it's passed around a logical ring of devices. A device can only transmit if it has the token. If it doesn't have the token, it has to wait. And the whole point of this is so that every device has an equal time to communicate and to not overstep anybody else. So, the real thing is the device, it transmits its frame and then travels around the ring until it reaches its destination. Once the destination gets the info, it empties out essentially the token and sends back an empty frame. Once the original transmitter gets that empty frame, it then releases the token so that somebody else can take their turn to communicate. So it sounds like a lot, but really when you think about how fast these things operate, our brains don't operate that fast. But the benefits are pretty strong, and that is, the benefits are it ensures that every device fairly gets the time to communicate, and it eliminates data collisions. And that's a huge issue because, retransmits add latency and cause reliability issues. In the industrial universe, this really kind of makes sense because it's all about reliability and low latency. So I'm interested to kind of to hear your spin on how you guys were able to translate this from kind of an outdated wired protocol and architecture to a fully updated and low latency wireless communication method. So really, what got you guys, Florian, what got you guys moving in this direction with this, and what makes your version of token ring viable for consistent, and fast wireless communication in industry?
Yeah, thanks. Well, what got me into that was basically this great idea to form deterministic industrial wireless networks, with this type of architecture, which is different than, let's say, standard access point client orientation. And if you think about the token in a cable-based sense is quite limited, because if the token is lost, then let's say a cable is cut, then the whole ring doesn't work really anymore. And if you think about that in a wireless sense, you have much more opportunities because you are in a broadcast medium, yeah, and the token not only goes between 1 and 2, everybody can listen to the token. So you can gain a lot in that architecture if you bring it into the wireless level. And everybody knows wireless is, let's say, from physics, not a clear stability when it comes of data transmissions. You never know, basically. Everything can happen. And with this token architecture, we're able to distribute information with the token wirelessly. Everybody can listen to this information, can save this information into the token. And so when the token comes back, which can be everybody in the system, let's say there might be some kind of route, which a logical route the token takes in a wireless world. And when the token comes back, it always comes back at a defined point in time, which is configured upfront. Then the station gets every information everybody else has saved into the token about the wireless channels. Because we take advantage of the broadcast medium, basically. Yeah. And this is one big advantage to take this architecture into the wireless channel. Instead of, let's say, a client listens to the packets and tries to make their own stuff, we get an end-to-end channel matrix distributed in real time at the cost of this token transmission to every station. And it's updated all the time. So when you configure a token ring network, let's say 16 millisecond cycle time from a PLC point of view, yeah, then every time the token comes back, this whole network is updated from its channel matrix. And this is very powerful information. And this is only possible in a way to leverage with a token ring architecture. Yeah, otherwise, you might get let's say, other possibilities to distribute information, but at other costs. So this comes for free in this architecture. So the token is still deterministic, yeah, but it gives us, let's say, all this channel information. And now, if you have this basis of information at hand, every station can leverage this information. Yeah. So we for example, change the route of the token if let's say, some links are not good based on that. That does the system automatically. But also we implement safeguard measures to really, because the token is essential. If the token gets lost, the system needs to recreate tokens and start, let's say, forming a network. So it's very crucial to safeguard the token for sure in the wireless channel. And we also use this information to safeguard the data communication. And clearly, the token is basically the heartbeat of the network.
Okay.
And it's just a logical way. So the data communication is a completely, let's say, separate thing. Yeah, everybody can communicate to everybody in that network. So there is no, let's say, access point client relationship typically. So everybody can communicate to everybody because it's a broadcast medium. So you can address everybody. Yeah. And that's the second big advantage of that system.
So
now,
it's not like it's not a mesh, but it does have some mesh-like qualities in the fact that it can redirect to other nodes that are part of that network in order, should a node go down or communication in one direction be broken. So it has that self-healing, so to speak, aspect like many mesh networks do.
Yeah, totally. It's basically a one-hop mesh. So in our network, typically everybody sees each other. Yeah, and you can think about so our packet structure, we discussed that a little bit earlier. We always address two destinations. Yeah, one is basically the primary destination where the data packet should go from not the network. Let's say orchestrator, but let's say the data path, for example. Okay. And there's a second partner which we address too, which is basically the fallback route. So these two nodes are addressed at the same time, and both addressed nodes listen because they're addressed. Yeah, and now two things can happen basically. The destination gets the packet, everything is fine because the channel is fine at that moment in time, and it sends acknowledgement, everything is good, communication done. In the case the other partner, which is addressed as well, which is always dynamically chosen. So think about a bigger network. There's
Okay.
something now physically in between. This link at one moment in time is good, and in another time there's a better link in the network, right? Which is part of the token information distributed. Then the other partner basically listens. Is there an acknowledgement or not? And if there's none, this partner, because it paid attention at the very beginning to that packet too, and basically saved also the content of the packet, just resends the packet at the within microseconds, basically. So no acknowledgement, packet was resent by the partner and not retransmitted by the original sender. Because guess what?
Okay.
This link is not good. So we have time and spatial redundancy in a combination in a real-time network thing. A mesh typically is not real-time. Yeah, you know,
Right.
at some point in time the packet arrives. Yeah, in our way, we use the mesh to really hold the deadline set.
So what does, you know, in the realms of industrial wireless communication, latency is everything.
Sure.
Everything that you were just talking about, that's kind of a lot to take in. But when your payload has to get from point A to point B in X amount of time, you know, you only have a certain amount of latency to play with. Does this process add a bunch of latency, or is it just about the same as any other wireless communication?
Well, the main question is what is the reliability of the set latency targets? Yeah. So basically with our systems, you can have 6 digits, 7 digits of reliability. Because of course it's always kind of a trade-off. How often do you retransmit until, let's say, the probability of the receiver is satisfied with, let's say, receiving the packet. The problem in the wireless channel is that in low latency time spans, the channel does not recover that fast. So especially in industrial environments, when it's not just a channel, which is fading holes and all of that, which is happening all the time. Let's say channel quality is changing all the time.
Right.
But think about you get something physical in between, and this thing is not moving that fast that it's going to be away in the next 5 milliseconds again. So in an industrial sense, this is quite important that when we talk about latency in our system, and if you go to our data specs, we don't match, let's say, this theoretical lab data rates other systems might have. We always giving you a guaranteed throughput, and guaranteed means holding the latency, and every packet which is maybe coming later is already lost in our denomination. And now getting back to your question, so this is also, I always like to extend the perspective, because a latency you can define, let's say, from antenna to the other antenna. I mean, that's just physics, right? So that's fast. It's also fast in our system. So it's as fast as every other Wi-Fi, because we're based on a Wi-Fi PHY. So there it's no different from a physical perspective. But when we define latency, we always see that as an end-to-end communication. So the PLC sends something, the client answers, and back. So that's for us, let's say, a closed loop. And every step in between also, let's say, how the packets are handled, let's say, in the driver or in the operating system counts. And that's when we talk about latency, typically, because everything else is basically not relevant. So when you say latency, we completely fine running one-on-one connections with, from a PLC perspective, latency of 6 to 8 milliseconds, sometimes 4, back and forth.
Okay, that's impressive.
If we have bigger networks, always bigger networks bring up the, let's say, communication latency, right? And remember, the token always takes its toll.
Right.
So at our cost of our token. So when we support, let's say, 16 clients in a setup, we run for sure 64 milliseconds, really deterministic latency of that profi-safe system, for example. Yeah. So this is, let's say, the area which we talk about latency. Yeah, it's not just the link latency from antenna to antenna. I mean, that's fast. And as I said, the retransmissions are kicked in microseconds. So this is not the topic. The question is, how does the packet go through the whole stack back and forth from Ethernet port to the other Ethernet port and back?
Well, that was an absolutely fantastic answer to my very open and unfair question of do you add latency? So no, that was awesome. I really appreciate that information. That's good stuff. Because really when it comes down to it, it's all about how much latency can the end application tolerate? And
Sure.
when you're looking at control systems, be it safety or standard controls, what your refresh rates are, how many misses you can take before you fault, and things of that nature. I don't know, Jeremy would have a better grasp on that with the safety systems that he works on. Most of my safety experience has been with crane anti-collision systems. So that's a little bit different, but you don't want cranes hitting each other because that is bad, in general.
Sure.
Up there with
that's
planes.
correct.
Yeah. So I have a quick question. So that's kind of interesting that you're saying you have kind of like a fallback address kind of built into the protocol. So you're sending the two nodes. So if the token is who initiates can either of those, like the primary receiver and then it's not random, but the dynamic, well, it might be random, but that dynamic receiver, do they regenerate the token, or does the original sender of the token regenerate it?
Well, you're talking probably about a fault tolerance. What happens if the token gets lost? Yeah.
Yeah, yes.
So maybe just the first part, because it's related to my explanation a little bit. So when we still are in the data transmission phase, the token always sticks with the sender. It does not go away. So it's still at the sending station, although other partners are allowed to send, basically get a sub license to send, for a specific time. But the token is still at the sender. So when we talk about data transmission, the token is still there and it has not been sent around because the station got the token and does what it, let's say, configured to do. When you talk about the token gets lost, so there are ways to reinitiate the token also by other station if the token gets lost. And the station is not always kicked out directly. So it stays in the network sense. I'm not sure, don't get me on that specifics when it's kicked out, but it stays a little bit longer, in order that maybe other stations can initiate a token so that the station does not leave the network at the first time when the token gets lost. So there are different mechanisms in the protocol established because it's needed, it's wireless, right? Where the token, let's say the heartbeat is kept alive a little bit longer than you might mean. And so there are some, so others can also initiate a token and then maybe the station is still there. After some time, it will be kicked out in a very short time perspective. But hopefully that answers your question.
Yeah, I think so. And then just another kind of quick question while we're talking about the packet level. So is this a modified 802.11 frame, or is it kind of like a purpose-built encapsulation method?
Yeah, so how it's implemented, basically we took the whole firmware of this Wi-Fi chip we're using, took it out and rewrote it completely. So also the packet structure is different. The headers are different, right?
So you have full low-level access to the chip then, correct?
Correct.
Wow. Okay.
So the idea was to not healing the inefficiencies of the wireless channel on higher layers, but directly as close as possible to the front end. And that also, explains, I mentioned at the beginning, we're 10 years around. So of course, it took us quite a while to come to a proficient MEC scheme running. Yeah. So the first demos we had were on FPGA boards, software-defined radios combinations. Then we moved to at that point in time open Atheros Wi-Fi chipset, which somebody hacked the firmware once and just published it years ago. And we took that and as a start to showcase to chip manufacturers this implementation basically already on a standardized Wi-Fi chip, right? Not on a SDR, which is much too expensive, of course, to run a product. And then we moved to a industrial automotive grade Wi-Fi chipset. And now we're still working on this older chipset. We also have access to newer chipsets at the moment. But otherwise you cannot do that. If you look at, let's say, other market players, typically they try to to do it on a higher layer. And things get much more complicated to influence the chipsets in Wi-Fi 6 and onwards, because let's say more IP is stuffed into the chips.
I'm hearing that from a
opens
lot of different manufacturers.
Yeah.
You're absolutely correct that Wi-Fi 6, 6E, and now 7, trying to manipulate that stuff higher up is much more difficult because of how they're building the protocols.
Absolutely. And so, back to the question. So we really built into our own MAC. Yeah, that's in fact what happens, based on an IBM token ring as a basis from a idea perspective. And now, of course, it's adapted to the Wi-Fi world, to the, let's say, 802.11 PHYs, basically. I'm also happy to join to give you more information in the show notes, if you really want to dig into further details.
I'm sure somebody out there does. I do.
Well, while you're not 802.11, you do seem to be adhering to the 802.11 channel structure for over the frequencies, correct?
Yes and no, depending. Well, in general, yes.
As far as like frequency channels, channel spacing, and how you divide that up.
Totally. So it's 802.11 phi. So there's no difference basically. So the physics is the same.
Okay.
From a regulatory perspective, especially in the States, we are running the same Wi-Fi bands, the same transmit powers. So typically lower and higher Uni 1 and Uni 3.
So you guys don't use DFS channels?
No, we don't use DFS channels, but we also don't do listen before talk. So that's another aspect which is specific to that system, because listen before talk brings in latency and complexity, of course.
Agreed.
Well, the good thing in the US and let's say FCC-oriented countries, this is not punished. Yeah, and it's also not punished in a way of transmission power. In the European Union, when it comes to more European regulation, some countries have, we are running typically in the short range device bands, which are even separated from Wi-Fi. So depending on where you are in the world, you have some pros and cons depending on the channels we are. But in general, we are in the 5 gigahertz. We don't go into 2.4 because we say it's just too much traffic and too much interference. There's no good way to run, let's say, systems which need a higher throughput in a way of, let's say, 10, 15, 20 participants. So we stick to the 5 gigahertz. And as I said, in Europe, we're completely separate from the Wi-Fi structure. And in the US, of course, we need to align with customers some channels, right? The good thing is also, I mean, we showed it at the Rockwell shows. We still can run in an interfered environment stably, but of course, it's not good for the others. Yeah. So of course, in order to be fair, there needs to be channel management. Yeah, which is standard nowadays.
So I totally get staying out of 2.4, especially when you look over the past 8-10 years. Just about every new IoT technology is all in 2.4. It's cheap chipsets. They're able to develop all kinds of stuff, and so they're able to throw everything out there in 2.4 with a very low expense on the R&D side, which then creates a very crowded, already narrow channel space. I totally get that. So 5 gigahertz makes sense, but I tell you. Thinking about this a lot, I think that your whole chipset and your whole idea and your whole structure, I bet that would be good over 900 megahertz for more longer distance communications, because that, especially when you're looking at things like wastewater and different environmental things where you got to pass that data, it has to get there reliably. Because you've got EPA reporting that is depending upon this information. There are so many companies out there. For example, we do a lot of work in pulp and paper at GPA. There is a lot of environmental compliance that they have to do and reporting that they have to do. And, water is used extensively in the entire paper making process. So, there's always very large environmental data sets that they have to get, maintain, and transmit, and they have to store for 5 years. And when there's gaps in that data, they get heavy fines from the EPA. So that reliable transmission, but it's also not cost effective to run a kilometer of fiber out through a wastewater field. When you can do that much more cost effectively with wireless, but then you're looking at your inherent risks that come along with wireless as far as interference in the spectrum and or data reliability on your connections. With this enhanced reliability of the token ring structure, given the nature of 900 megahertz and the distance that it can go and what it can penetrate reliably, I could see this as being a great fit in that spectrum.
It is. I agree. It's just a question, of course, of overhead in the system and let's say packets. So when we are talking about industrial systems like a Profinet, ProfiSafe, we talk about big packets in comparison. So in that sense, we have not really gone into that so far. On the other hand, we know there is a lot of interest. So I'm not talking about, let's say, all these, let's say, sensor data generated and sent, let's say, massive IoT deployments. So you have a lot of options out there. Yeah. So when
you still have things like e-stops for motors and different things like that require safety. So, and that's more specifically what I'm talking about.
Yeah. So in that, so I just wanted to make the, let's say, the clarification. So in that field, yes, it would be very interesting. Yeah, we have not thought about porting it to another chipset. Typically, these chipsets are, let's say, not from a computing perspective. So if you port something into a Wi-Fi chip, this Wi-Fi chip has also internal processors which have some power, right, to run, let's say, the data streams. Let's say the IoT chips, let's say 900 megahertz and so forth, are maybe not that powerful. So it's always a question: are you able generally to port? Having said that, we are looking into this actually, and there are also other interesting options, which is not, let's say, our mesh structure. So right now, maybe it's a side topic, and if that's interested, we can have a discussion about that. But right now, we're looking into a revival of the DECT, DECT. Let's say this. It's also in the US, I guess, but it's also strong in Europe. So it's Mac. Curtis? What is the expression?
1.9 gigahertz.
Yeah, it's a DECT. These typical DECT phones you have in your.
What'd you say, Curtis? What frequency?
It's 1.9 gigahertz. Sorry,
okay.
I might have said megahertz, but gigahertz. Let me look.
Okay.
Yeah, so it's basically the digital enhanced cordless telecommunications, DECT. Okay. Anyhow, so this is interesting because there's a lot of movement here in Europe, at least, and it's applicable to the US because this frequency band is unified and also available in the US.
Okay.
And the good thing is we're working on a real-time stack for that at the moment. So we already had implementations for ProfiSafe point-to-point, which I'm not talking about, let's say, massive network in that sense. So that's let's say the differentiation. But let's say point-to-point links, which are not 2.4, not Bluetooth, but also not Halo.
Right.
Different. With a real-time focus. So 1.9 or 0.9 gigahertz, that's the frequencies we can use. Also,
and that's still with the token ring architecture?
No, that will be more like a TDMA structure, basically.
Okay, okay.
But I just mentioned that because the token makes a lot of sense when you have a capable PHY, a capable processor in the chipsets. It loses its advantage. Let's say the longer the distances are, the less the requirements from the networks is. So the higher the latency gets, the more options you typically have in implementation. So yes, this is an interesting thing. We have not dared to migrate it yet.
Well, hey, I appreciate the sneak preview, and to be honest with you, I'm a sucker for anything 900 megahertz. That's kind of like I know it's the redheaded stepchild of the wireless universe over the past few years, but again, I hold high interest because just the different things that you can accomplish with 900 megahertz that you can't accomplish with the higher frequencies, and some of the actual projects I have been able to save by shifting to that frequency range, and making things work and making the client very happy, just reinforces that fact. So I'm always looking to be like, hey, 900 megahertz, why don't you go that way?
We did a post on LinkedIn on this system with this first prototype. So I'll put it in, help you in the show notes. And so
Yeah,
everybody
I'll
using
be
that
happy to link it.
can
Absolutely.
have a look at. So it's a Profi-safe system running in DECT and with these kind of features in the future to, let's say, have a couple of 100 meters, kilometers, 1 or 2, running really deterministic, for example, Profi-safe or SIP safety links.
But what hardware platform would this run on?
This is actually a Nordics chipset. And it will be integrated in our next upcoming architecture, which is kind of an edge platform. And
So the
yeah,
new edge device would be capable of running this?
in the future, yes. So right now,
Okay.
not, but it will be integrated. And this so basically, it's then again the transparent communication. Yeah. So basically, you have your Profi-safe, your SIP safety on the one hand, and we just push the packets through. And as I said, this short video on LinkedIn gives you kind of an idea what I mean with it.
That
Have a-
no, go ahead, Jeremy.
I was going to say, as we were kind of talking about the frequency and some of that stuff, have y'all looked into any sort of like, simultaneous client communications, like some of the newer protocol support? So like the OFDM type approaches where you split the frequency band?
Yes, of course we did. So the token. So let's put it like that. So the Wi-Fi, the current Wi-Fi generations all have, let's say, a very strong access point, which, let's say, gathers the information on different, let's say, sub channels, yeah, from the stations or the clients. We're actually working on that to use it in a more deterministic way. Yeah. This approach, as we already shortly discussed, so the new Wi-Fi devices are very powerful because, of course, they need to work a lot to make this work, yeah, on let's say OFDM A-frames and getting all the answers from the clients, for example. And this is not really matching the token ring architecture in that sense. So we as R3, we look into being a provider, and to some extent we are, in bringing to your customers different options for different issues for different systems. And the token ring, the echo ring architecture is, I think it's great, yeah, because it gives a lot of flexibility. We already also have a seamless roaming, so you don't have any roaming times in our system and still holding the deterministic. So you also can scale the system, which is great. But of course, if you go, let's say, more into the newer generations, then things get more tricky on the wireless chipsets. Yeah, we also have access to a Wi-Fi 6 chipset at them already, and trying to work on that. So there will be hopefully some news at some point, but it would be a kind of different scheme. And this scheme we're working on is much more optimized than for, let's say, IT/OT convergence, TSN networks, and things like that. When you also need to have PTP transmitted and things like that, so time synchronization next to determinism on the data links.
Mm-hmm.
But of course, I'm drifting away. So
Okay, yeah.
that's a whole different world again. But yeah, but good question. So yes, we're looking into the new PHYs. Yeah, DEC PHY, Wi-Fi 6 PHYs. But we try to use them smartly. To use them there where it makes sense. And we're also, let's say, overall system costs and handling and all of that is making sense.
One aspect that's worth noting too, we have the capability of operating in the CBRS bands. So we're really more looking for an industry partner out there that would really, be interested in developing this out, because of course it's subscription based, but you might talk a little bit about that as well.
Well, of course, I mean, obviously we're hitting so many different topics and hopefully not confusing anybody. But the idea of that is, so the whole 5G wave, yeah, which has been running through the whole world for quite some time, and about, let's say, private networks operated by the telcos and private networks operated by, let's say, the factory owner. Yeah. We have been quite early part of the 5G world in terms of working in, let's say, standardization committees. In Germany, it's called 5G ACR, yeah, which is kind of a bigger organization right now. Still, it's a free GGP world, right? So, and free GGP is all about I own the frequency and I run the networks and I define the networks. There are also other ways to use it. And there are in different countries, and in the US, it's the CBRS, which is kind of, let's say, more openly regulated. So you can run your private 5G there, but you possibly can run also other technologies if they comply, let's say, with the framework and, let's say, local access. And in Germany, for example, we call it campus, which is basically also a frequency dedicated only for private deployments, owned by the factory owner and not run by the telcos. Having that forward, so we already have versions which can tune into these bands. Basically frequency converters built into our product already. So everything what you already have on a deterministic way in the echoing network, in the BridgeE, in the standard 5 gigahertz bands at the moment, we already have it run into in, let's say, local frequencies like 3.5. So different architecture, different way, definitely cheaper than having a 5G core somewhere. But also kind of a side topic, maybe. Yeah, I'm not sure. Don't want to confuse everybody here.
The CWNP Wireless IoT Track is the only certification program available that not only covers wireless IoT protocols in common use, but IoT as a technology and solution that is revolutionizing industry and business at the same time. When you work through the IoT track, you learn the protocols, the devices, the data, and the applications that bring the true value IoT has to offer. And for those with the tenacity to persevere, the world's elite IoT certification completes the process and the Certified Wireless IoT Solutions Expert credentials. If you want to be in the cutting edge of what's happening in technology, you won't find a better certification program for the Internet of Things. Well, there's definitely no lack of interesting topics to cover as far as R3 is concerned. I do want to circle back to our conversation about Spectrum, and I posted this on LinkedIn, and can you guys see my screen there? It is really cool just how tight you're able to maintain with very little bleed over outside of the channel I had you broadcasting on. So I had you on my lab radios. You're on channel 153. Like I said, I'm a visual learner, so spectrum analysis really is kind of a key thing for me to help me understand how things work. But one thing I'm curious about, I don't know how much you've dug into the spectrum analysis portion of your stuff, Florian, but it's really cool. But it just seems like right down the middle of the channel is this pretty clear, like almost spike of communication that's a little bit heavier than it is all around the rest of that. And I'm curious, is that where the token management lies? Is that kind of like control traffic, as it were? You know, when you look at things like Bluetooth, they have control channels, and those are usually easily to identify on Spectrum because it's a much heavier transmission spike than the rest of it as it balances across the network. So through the channel width that you're using, do you guys kind of specifically focus that token management and part of the spectrum? Is that what I'm seeing here, or is this just some kind of random anomaly that I'm seeing and I'm chasing ghosts?
Uh, well, I mean, it's nice to see. I mean, we have similar pictures of that holding, let's say, the boundaries quite tight, of course, especially when we have larger deployments. It's important, yeah, not to have this out of band emissions. And of course, I would say this chipset we're using is well defined and does a good job. Yeah, and let's say in a on a Wi-Fi module, you have a lot of filters left and right, so it's not just, let's say, an antenna. Yeah, and so that's one part I would answer to this question. And the second part you mentioned specifically, so we always have a 20 megahertz channel, so there is no, let's say, specific band inside.
Okay.
So it might be only an anomaly. Yeah. So I would not. It's not tied to the, as I said, to the how we generate packets. So it's still the physics of a 20 megahertz channel.
Okay. Well, I mean, what I'm showing too is probably a what maybe 10-15 minute portion of the recording. If I shorten it down to just a couple of minutes, and you see how it thins out, but
Yeah.
you can still kind of see
Interesting, yeah.
that.
It could be. I know it might be kind of calibration topics coming in. Not sure if they happened at what time. Maybe you.
Definitely something I'm interested to learn more about. So if you guys are agreeable to it, I think at some point we're going to have to do a deeper dive and put it on the YouTube channel so that we can specifically look at stuff like this. And you can either tell me I'm crazy, or you can say, no, really, this is part of what we're doing. So
Interesting. Okay, well, we take that as a discussion point. Yeah, I'll ask the guys if they have seen something similar during the project or during development.
So I'm curious, Sarah slash Meg.
I like that one, Scott. So she always gets now the name Sarah.
Absolutely.
That's right.
Gonna stick.
I'm curious, you've got 20 plus years of experience in the wireless universe, and you've been with R3 less than a year. What is your take on kind of everything that I know it's kind of broad, but I'm sure you have quite the varied amount of experience, from different directions. What is your take on this technology?
Well, my background is in wireless, but it's, I'm an analog girl, if you want to call that. I've been around since analog days, and then was able to introduce the 3G, 4G, and then 5G technologies. So my experience with Wi-Fi and the fundamentals around that is all brand new. So that's been interesting, but the basics are the same. The terminology, the concepts. I have an RF background myself. That's where I started. So that part has been really a smooth transition. For me, though, the experience has been just the industrial market, right? Not having that. I usually worked with the service providers myself. So one of the most obvious observations I've made is the newness of wireless for a lot of these people that are so used to using Ethernet cable, and being able to have those conversations with them over and over again, and making them realize that this is not new, right? There's a lot of new technologies being merged together, there's older versus new ones coming. And I think it's just a matter of re-educating or educating people that have not really dealt with wireless, but the fundamentals are there, the technology is proven. And I just find it really interesting that the whole industry itself is all new to this, and that there's a lot of things that can be done with this product itself, and it's several different verticals.
That's a very valid point in the grand scheme of things. While wireless has existed in industry for the better part of 20, 25 years, it's been such a very small, narrow piece of it that the vast majority of those in industry in general have no experience with it. And many of them just kind of have either no opinion or a negative opinion because they're looking at it from an old school point of view because they hardwire everything.
Right.
I would say, and Jeremy, correct me if I'm wrong, I would say probably in the past 10 to 12 years, wireless has been leaps and bounds growing in dirty manufacturing in general. And then with ride safety and a lot of those aspects, adopting it, proving that you can safely run safety systems over wireless communication, that's opened a lot of doors for industry in general in this whole wide swath. So
Yeah,
Agreed.
I think definitely, what Meg was saying is, customers are generally kind of skittish or scared to bring some of this stuff in. But I mean, it's painful having to wait 3 months with a machine down with a lot of the like slip ring technologies. That's usually seems like kind of the best in for somebody to say, hey, we can bypass this link with some sort of wireless capability. And that usually kind of gets them the warm fuzzies.
Right, right. Definitely.
Yeah.
And as I've said in the past too, there's so much wireless in people's homes. We just recently moved into a house and everything's wireless. You can't even get a wire right in the wall. So as people become more accustomed, even within their day-to-day, incorporating wireless, I think that helps bring it into the workplace too, and realizing that this makes sense. It's simpler, it's flexible, it's scalable, perhaps less expensive than trying to pull a bunch of cables and hiring and dealing with all that bidding that potentially could occur as well.
Well, I will tell you the one dedicated wired connection in my house. My son has decided he likes computer video games, and I had him crawl under the house and pull his own Ethernet cable.
Very good.
That's awesome.
Nice.
Well,
hey, if he's willing
Keeps
to
him
put
out
in
of
the work,
trouble.
Hey
Keeps
man,
him out of trouble.
if you want to reduce your latency, go play with the spiders.
yeah. I don't know. I make my kids do wireless labs with me out in the backyard in the summertime. So if they're going to eat up all my bandwidth, they got to do some work for it.
They just roll their eyes at me and they're like, I don't know what any of that is.
well, next generation.
Yeah.
Right.
Yeah.
So Curtis, on a fair, you've been supporting a fair amount of installs of these. In your opinion, how does it seem to be comparing with other technologies that you're seeing when you're installing a new series of the Bridgie radios or the newer versions or whatever out there in the field?
Sure. Well, I don't encounter, in the wild, a lot of other technologies. Usually when we're brought in to solve a wireless solution for somebody. So generally speaking, where I run into more of those topics would be like from the soft sales perspective. We're building the brand, so identify a customer, somebody's come to us, maybe Meg has made an outreach, and so I get brought into the conversation, and then at that stage it's really because we try to be pretty open and honest with customers about their expectations, managing the expectations for them as far as what they need and what they want. Latency is one that you all kind of just touched on, but what is real time? Well, real time is a relative term, right? So
That's fair.
Do you need the do you need real time performance? Are we talking about production data every 30 seconds off the floor? Well, to somebody that's real time, but that's not really real time. And then, this technology was developed, it was purpose built for industrial Ethernet communications, very specifically. We fit that niche, certainly, where we can get into these low latencies. And the two aspects there are ultra reliable and low latency. The reliability is just inherent, right, with the token ring architecture. Right, you're going to get that reliability, but the latencies, not everybody needs, to get into the, sub 10 millisecond range, which one of the differentiators with us. I know ProSoft, they can do ultra fast roaming, right? But we really can get into. We had a development topic come up, and it was spurred by a customer request where, well, can you get into SIP motion? Well, I mean, we can do SIP safety, but SIP motion then is, now you're talking about servo drives or whatever.
That's a whole different application,
right? And so that kind of kicked it back internally, and they said, well, all right, we don't see any reason why we can't, but we're a ways off yet from wanting to advertise it. Let's test, and then then maybe get an application out with a customer that's a little bit more flexible. They have a real need, but and they don't have a high expectation that we're going to deliver first run, and let's test it and let's see, and then once we get something working out in the field. So
no, that makes complete sense.
I know that didn't really get to your question specifically, but again, I generally, my work from the commissioning side, I'm not encountering other technologies out there.
Because you all
Generally.
right. So you're brought in for very specific scenarios and whatnot. So it's
Correct.
not really
Yeah.
a competition aspect. It's a, hey, we need what you've got. Come
Yeah.
Right.
deploy this for us.
Either we've tried something else and hadn't had success with it, or we're looking for maybe we haven't seen advertised capability from other customer or other providers,
Vendors.
of technology. So yeah.
Maybe I can add here some aspects which I think are important. So of course we are quite a very knowledgeable round. So we know what counts in the end is what packets are transferred on a cable based or Wireshark basis. That's what we look at, and that's what I know you also look into that, Jeremy and Scott. And it makes a huge difference if you're using different industrial protocols, the way they react, the way they work. And now, typically, you don't have a pure system. Now you get much more monitoring data over these links. So from a wireless perspective, it's every packet counts, and every packet is important. And you need to understand which is the priority of each packet and the importance of each packet, and let's say how cyclical they are. So we know SIP safety systems or SIP systems with different cycle times, meshed up. Profinet, ProfiSafe is a different type of story. Packet sizes get bigger the more clients you have behind. SIP, you have separate connections. And I can talk about, let's say, other protocols which we have been run into, which even make it even more complicated to run. So when we designed the system, we always looked into how can you, to some extent, maybe also a cost you need to take in, but how you can configure it to the application you have. And maybe back to the token discussion at the beginning, we can configure this token behavior in a very specific way. We can say this station has more data transmission than another station, so the token stays longer. We can specify how many retransmit we make. Do we do one or do we do two? So we can really adjust the optimization of the reliability. We do have deep packet inspections in place, which basically looks at every packet coming in. We have a lot of different priority schemes, 5 queues, which we can put in our system. And first we work off, let's say, the most important ones. Yeah. So what we do is quality of service in our devices, which makes it easier on the wireless channel to work with, because everybody knows it's limited first, bandwidth wise, and secondly, the channel is unstable. You don't know the stability of the channel, so you need to manage, let's say, what you put on the channel. And that's, let's say, how our system is set up from the beginning. If you take a standard Wi-Fi device and let's say have some optimization on higher layers, you will never be able to really work on the front end to put what the system puts on the front end. So if you have a standard Wi-Fi with a standard Wi-Fi firmware, it does some things and you don't know what it does and you don't know when it does. So the only chance is you work it around on driver or higher layers to at least somehow influence that. So we really took that part of the equation out and worked around that already in the firmware. So we have a bunch of different mechanisms on different layers of the stack. It's the token, it's the mesh routines, it's the interference robustness in a sense that we don't react because we don't do listen before talk, but also the industrial prioritization we have in place, where we can really, let's say, organize the packet streams in a way that it's following the priority and not just bursting it. We have aggregation in place. If you have a lot of SIP connections in one link, now we aggregate packets in order to take out, let's say, a lot of packets out of the channel. Yeah. So this, let's say, opportunities on the configuration side is basically bringing a lot of versatility in our product. Of course, you need to understand it. that's the other part. But I would say when PLC started, PLC, safety networks, you also need to know your shit. If you don't know it,
Oh, totally.
you're screwed also. So that is for me not the excuse not to touch our system, because if you really want to make wireless work, you need to understand what's happening on the data paths and how the network works and how the PLCs react on, let's say, different latencies, timeouts, whatsoever.
Absolutely.
And that is a challenge in our market where we fight for.
Well, Florian, that's so funny that you just went into that, because that's my I had QoS, COS. I was just about to ask you about that. Can I tag one more thing onto that and ask? So you said you guys do like deep packet analysis. What about like monitoring from this? Like, do you have any kind of built-in mechanisms with Rockwell or Siemens where you can get like SNMP information from the radio or things like that to kind of just
Yeah.
find, like, is the radio alive or anything like that?
Well, right now we're not integrated in these systems specifically. As far as I know, well, the others are to some extent integrated, not generally, I would say, because sometimes a Siemens system you still need to configure separately out of the tier, right? So that's one part. And right now we do have separate systems which look at the networks specifically. So the problem is well, it's a design decision, yeah, in part. So the more you integrate into the system itself, the more you bring data into the system, which you try to avoid.
Then you're adding overhead into the transmission.
So yes, we have separate systems to monitor, which also can be integrated into management systems with triggering alarms and things like that. We recently implemented is the Ethernet port alive or not for DLR networks, interestingly. So we signal basically back from the front end, do we have a link or not? And then we switch on, switch off the Ethernet ports, which is kind of an implicit mechanism regarding what you mentioned, just. Yeah, and there are some ways to poll data our devices. We have not talked about one feature we have is, I think it's a great feature, of course, but of course it's a feature and it needs to be used. But we have kind of a real-time control interface to our device, meaning we use UDP packet basically to control our device. So you can switch on our device, you can switch it off. We use it for our seamless roaming technology to really switch channels within microseconds and to log on quite fast with, let's say, signaling over the backbone. But also we can change the antenna on runtime on specific information. For example, because we know we're in position A and then better in position A, use left antenna instead of the right antenna. So this type of interface also opens up the opportunity to pull data out of our device. And we do that. We do not do it, let's say, on a general, let's say, monitoring at the moment. Yeah, but we implement it here and there in customer deployments to pull out data. Is the network still alive or not? Or let's say, are the nodes there and things like that. So basic things in that sense. Yeah. But we don't do scanning at the same time and transmit. I mean, that's kind of overloading everything, right? So we have separate devices, separate monitoring net software, which can be installed if it's needed. Our philosophy is we install it and it works.
Well, Curtis probably has run into this a bunch, but some customers really do love a scoreboard where they can watch a little chart beep and boop. So is that kind of what you're talking about too, is kind of like a dynamic antenna selection, or like knowing the positions or being able to send a UDP packet? I think when we talked about this previously, that some of that's like how if you, like say an AGV or something like that, if you have a device that's in motion, you can actually kind of say, hey, here's going to be the next channel you're going to roam to. And so you can have more than just, is it right now you currently kind of keep 3 channels in memory? Or somewhere around there.
Well, yeah.
Or
So
like scanning channos, or.
So you mentioned basically 2 topics. So one is the roaming, how we do that specifically. So this UDP thing is kind of really a universal way of talking to our device for many things. So we have written function blocks to be built into PLC, but you also can build it into, let's say, the mobile PLC, for example, or whatever, let's say, device, mobile. But you also can run it from a fleet manager, from a central, and send this signal over our network. So it's kind of versatile, wherever you want to have control and deterministic behavior of the network. And that's what you get with this interface. When we talk specifically about the roaming, yes, you're right. At the moment, we do have implemented 3 channels, which are pre-configured, designated. designated, pre-configured, and with that we do typically the roaming, and that works kind of really instantaneously, yeah, switching from one channel to the other. With this, we also did bigger deployments, yeah. So it has its limitations with this free channel approach. It has some, let's say, there are limitations why we have not extended it so far. We also, let's say, another bigger implementation, we have kind of basis areas defined where we basically load new configurations. So it happens quite fast, but it's kind of a short position, and then we do something else in a different part of the network. Yeah, so we use it for roaming, and we use specific roaming spots where to roam. So if you take a leaky coax environment, you're completely fine with 2 or 3 channels. Even the slotted waveguide designs we did. So even very easy, and even broadcast domains, we did bigger implementations, yeah, with these 3 channels. Yeah, it's a nice way to control the device, yeah, and we know competitors did implement specific ways to control the roaming in order to make it clear, because you always have edge cases, and the problems arise in these edge cases.
Right.
So. And
well,
that's
that's a perfect kind of response to the question I was asking. So, because I could see, so it's not just the roaming or the channels, but you can kind of update the entire configuration as needed. Because we'll see stuff where it's like, a vehicle rolls onto an elevator, and then maybe you need to increase the power or decrease the power because now all of a sudden you're in a just a maniac's level of reflectivity or something. So.
Yeah, so with our device, you can have different zones working differently. And also, there are some examples now when you have, let's say, well, of course, generally HEVs don't need this deterministic wireless. So they're equipped with standard clients. And if the network is set up quite okay, everything is good. You have, let's say, the 10%, 5% of applications where you run into issues. So they try to overcompensate with access points whatsoever. I think there are smarter ways to do it. Let's say having specific areas running maybe a second device, turning it on only in that area where you have issues, like, for example, such a network of ours, or you use this device as a primary, of course, for your OT network, which is separate from your IT, which has some advantages as well. And then you can basically tune it on, turn it off in different network segments, also configure it to connect to different safety infrastructure PLCs. If HEV has one area to connect and goes to another area, so you can play around with this.
Or maybe you have a situation where you have a vehicle or something, part of your process, it docks, and then now all of a sudden you need this to kind of collaborate with another system.
Right. So this gives quite a nice opportunity to reprogram a predefined load, a predefined configuration on spot, on trigger, where you need it.
That was awesome.
Yeah. Well, yeah, that's great. And Curtis, you have probably seen this too, but that's kind of, that's where it becomes collaborative on the end customer too, where it's like, are they exporting that, that location data, or they have to trigger that from PLC? And even some of the stuff we're doing is not necessarily like PLC, like ladder or STL, but just, I think it's C. Oh man, this is going to be embarrassing if my colleagues hear me say this, but some of our stuff is like not necessarily even running on PLCs, but it's still doing controls type traffic now. I mean, it's wide open.
So I'm curious, because I know Jeremy's been asking about this, and we were giving Curtis some grief about it over the weekend. Do you guys, for packet captures, do you guys have a parser for your data when doing Wiresharks over the air to kind of pull your data out?
Well, we're constantly evolving our capabilities. Wireshark is, the complexity of Wiresharks, and try to analyze it. Well, we work with parsers. We do. We also build additional tools to analyze these Wireshark dumps more quickly.
Okay.
That's one path where we support very in detail, let's say, on site if needed. I just came from a workshop last week with another company. Actually, we supported there on let's say Wi-Fi stuff, which is also part of our capabilities, where we looked into specific roaming events, yeah, where let's say the client wanted to roam, and I know the complexity of this Wireshark dumps, getting into this point in time of the massive data and then finding the specific pattern again. Yeah. So yeah, we're working on these things right now. I mean, it's a case by case parsers, maybe if that's specific. For our, let's say, standard network analysis, we do have available, let's say, templates running. When it comes to this monitoring at the beginning, I mentioned, we do it differently. We look into, let's say, is there interference? Is there something changing in the data pattern behavior? And just have, let's say, harsh thresholds defined. If that drops, you get an alert. So on that sense, when it comes to continuous network monitoring, let's say for end users, we look in, let's say main KPIs. Yeah, and not going into really Wireshark detailed analysis. This can be then a second step if this is really not successful.
I was using I use IPA from MetaGeek. I don't know if you're familiar with that or not, but it's their packet capture analysis tool.
Mm-hmm.
And I wasn't having much luck pulling the traffic off of these bridges. And I don't know if I'm just not tweaking my settings properly or whatnot, because I'm interested to see in a dump what that token ring looks like. You know, I want to be able to spot that and say, hey, look, this is a token packet right here. It's telling me that that's what this is. You know what I mean?
I know what you mean. I think that you need to understand a little bit more about our packet structure in order to do that probably, I think, instead of taking standard tools which don't look into this. Yeah. So let's have a chat about it. And I think that's completely doable to help you with that.
I tell you that the idea of doing a deep dive is getting better and better all the time. So kind of to wrap up today's show, I really wanted to ask about use cases and what are the primary use cases are you guys being deployed out there currently? What are you seeing the most of that you're bringing to the table? What areas are you guys really excelling at as far as industrial communication?
Good question. In general, my answer would be if you go to a Siemens page or to Brosov page and you see, let's say, the standard verticals they work in, that's pretty much also working for us. I think that the main things we do are really in factory automation and in automotive or in other factories, and also in warehouses in, let's say, specific areas. That's kind of the main verticals. I mean, we did work also in the amusement ride area. We also did in the stage, let's say, theater area, but we also worked in public transport.
Oh, that's interesting.
As I said, the main parts are factory automation. And there, I would say we did a lot of things. So when you think about the capabilities of the system, I mean, in some areas we have, let's say, specific competitors which are dedicated to some specific use cases, yeah, which we compete with. So when it comes to more like point-to-point connections, smaller networks, so you might see some Bluetooth connections here and there. So turntables, slip rings. We do a lot of work right now in the robotics fields when it comes to the connectors, the tools of the robots outside. So right now we're working with some automotive guys to replace the cable packages around the robots in that field, which is interesting. So we basically have a standard configuration for 8 millisecond Profinet, and they just put it there, even just point to point without using the third part. So even without the mesh, it works quite fine. So that's something we do. We also work so that's, let's say, the more like the point to point topics, which we have a specific say. The second part is more like, you can imagine the token ring is nice if you, let's say, have it's kind of decentralized network architecture. So the roles of each device is the same. So basically everybody has the same capabilities. There is no one node which has more like an access point client structure. Yeah, so everybody's the same. So we can we run with an HME manufacturer in Germany, like how you call it, when you have two HUVs and they want to do something together. and they transport a bigger part. So they are building a moving echoing network through the factories next to their standard Wi-Fi. So something like that we did. Very easy, let's say small working cells optimization pickups where safety comes now more into play. Just dedicated networks point to point. So that's one part of the story. And certainly there are some competitors because smaller networks, you don't have the complexity. So there are maybe you have more means to make it work. The second part is, let's say, larger implementations, bigger networks, 5, 10, 20 devices, up to 100. So there's a bigger area when it comes to overhead monorail systems. We did a lot about cranes, so big overhead cranes. Just to give you that example, skillet systems we did with all sorts from broadcast, let's say really standard broadcast, to leaky implementations, leaky coax implementations, or slotted waveguides.
So even though how you do things on the back end is kind of unique with the whole token structure, there's the use cases are not niche use cases. These are more across the board use cases for wireless in general that your solution fits into. Okay. That's kind of what I suspected, because even from just what limited I've played with my lab radios, you can see a lot of different applications that these would easily be able to fit into.
And so far as we progress now with, let's say, being in the market, and just for the history, I mean, 10 years is quite a long time. It took us quite some time to build up really a whole stack, a whole product. Yeah, it's not just a firmware, but really integrating into a really dependent system, from an end-to-end perspective. And then basically we were hit by COVID. So we had 3 years of not doing marketing at all. So that's kind of the story why it might be not really known to the US that strongly. Having said that, the other part, so we fit to different use cases. On the other hand, we also fit to different industry protocols. We don't focus only on Ethernet IP. We don't focus only on Profinet. So we can work with both, but we also work with CC Link from Mitsubishi, for example. We work with a lot of specific safety providers like pills. We work with SIG devices and so forth. So this protocol, and that is the unique thing, you can configure it in a way to work with different industrial protocols. And that's, let's say, how we're now getting more and more into the markets, more and more into systems, also with more and more different vendors, which are also looking into integrating it into their original devices too. Yeah. So a bigger area. Yeah. So
that's awesome. That's awesome. Jeremy, any final thoughts from you, sir?
Let me look at my notes.
Real quick.
Well, I think well, we didn't really hit on the Edge X stuff, and so maybe if you wouldn't mind, give us kind of a preview of how you see that device or that product line being applied.
Yeah, thank you. I mean, just in a couple of sentences, I would say, because it's a whole new architecture by itself. So the idea of our, let's say, upcoming product line is to combine compute and communication and connect, basically, and connect also in different sorts. So the Edge platform is basically a strong compute edge platform, which is capable of running PLCs, and which we showed at the Rockwell show as well. So we integrated a soft PLC there. We have direct connects with CAN and GPIOs on one hand to really
with CAN networks, huh?
It can run. So if you have a CAN, and we implement CAN in we use Codesys as a platform, right? But you can use CAN there, yeah. So we can convert the CAN.
That's interesting.
Yeah, and on the other hand, we look into different the connect part, the wireless part specifically, will be flexible in the future. So you can have a Wi-Fi 6E, which we showed already at the show, 6 gigahertz support, modern, let's say the most modern chipsets on the industrial side we could have access to, but also it will be able to run our echoing itself if you have, let's say, more specific needs. And also what I mentioned at the beginning, the DAC, that will also be a part of the solution. So the Edge platform is a flexible platform to integrate compute if you need it, So you can have maybe compute on the mobile client and use it as a bridge on the infrastructure. Yeah, we have, let's say, at this point in time, a software switch. So you can also, let's say, use it locally to have a smaller network as well. It is also going into the direction of TSN in the future. So there are already TSN files on it on one part, and the other part it is built up as a secure platform with secure elements to really also go into that specifics in the future if needed from the application.
And is that on this data sheet in the show notes? Does it support an onboard soft PLC? Is that?
Yeah, basically you can use a Codesys soft PLC environment to run it.
Nice.
And the idea is, of course, things get more consolidated. It's a cheaper approach for everybody, less devices, less wires to integrate. Of course, in the market, you have, let's say, the bigger players who do that on their own, on their IPCs to some extent, sure. But there's, let's say, a bunch of players which are not capable of such complex systems.
I like it.
Yeah, that's kind of exciting, really. Being
So
able
we
to
have
bring that all the way to the edge like that.
And we will have, I will shortly have, hopefully, a post where we also see the token ring already implemented in this architecture.
Well, that's awesome. Curtis, you were about to say something a minute ago.
Yeah, well, maybe a missed opportunity. I was gonna just kind of lay out a use case that we had come up here recently. Yeah, it was in this particular use case, it's AMRs, and they're actually, AGVs, AMRs are safe on their own, but the AMRs are having to move into a production zone. So, a good example for us is where we're taking over the safety handshake, where the AGV, or it's an AMR, has to go in, mute the light curtains, the floor scanners, then it's going to perform whatever task, and then come back out and switch everything back on. So, that very specifically fits the niche that we're very, very good at, and competition would struggle with.
Well, that's cool that you actually have niche areas where you excel at, but you still are competitive with multiple other deployment types. So that shows a lot of flexibility in your radios while still maintaining a unique architecture on the backside of it. That's pretty interesting. Actually, that's really interesting. Final thoughts before we close it out?
Well, I love the podcast with you.
Yeah.
It was great.
I really appreciate you guys taking the time and joining us. Florian, I know how busy you are, and Curtis, well, we're just going to keep bothering you.
That's what I'm here for.
And it was great having Meg/Sarah on the horn with us, having a lot of fun.
Well, when we get back together, I promise you it'll be changed.
Oh yeah, well, I hope not, because then I won't
It
have
is
anything to
kind of a
message you
fun
about.
little stick. Yeah, I get
Sarah,
it.
it doesn't
Thanks for
matter.
having me.
You stick to it. I got once a nickname and it never got away. So
Exactly.
I've got some
in my
inappropriate
emails,
ones.
I will now refer to you as Meg/Sarah. That's how that's going
Oh
to work.
boy. Okay.
Wait,
So do
maybe
you-
we
do you
reel,
think that
reel in
when-
reel in a Back to the Future clip in
Oh,
there.
yeah.
I don't know.
Yeah. Yeah. Where's the Giga?
Well, I was gonna ask if you could mount one of these on a DeLorean.
There we go.
Does
There we go.
There
and
you
does
go.
it have 1.21 gigawatts of impedance?
well, then,
With a straight face. Love
with
it.
that power, we would send our signals through time for sure.
Well, as long as you don't need plutonium to power it,
Oh.
and you're not buying it from guys in a VW bus running around, I think we're in good shape.
There we go.
There you go. Awesome.
Well, I want to thank everybody again for taking the time, and this has been fantastic. I do want to explore doing a deep dive on YouTube, because I think this would be some great material to look at and dive deeper in. Good times, guys. Thank you again so much. I really appreciate it.
Thank you.
And thanks everybody for listening in to our first year anniversary episode.
Woohoo.
Yay!
Thank you for having us. It was an honor. Thank you.
Thank y'all.
Very good. Thank you. Have a good day.
I guess.
Thanks for listening, everybody, and we hope you join us on our next episode of the Industrial Wi-Fi Shop.